Hi, my name is Stanley Shen and welcome to my video covering kinematics. Kinematics, which is the first unit that most AP Physics students study, describes the motion of an object without considering the forces that cause it to move in the first place. For AP Physics, most kinematics problems will only cover objects that are either not accelerating or accelerating at a constant rate. In this review video, I'll first cover one-dimensional kinematics, then move on to two-dimensional kinematics. At the heart of this unit are the kinematic equations. Most kinematics problems for AP Physics 1 can be solved with the four equations that I list below. However, it should be noted that each class seems to have a slightly different variations on these equations. I've listed the forms that I find most intuitive to memorize and use. However, you should also experiment with manipulating these equations into the form that you find most easy to memorize and use. The first three equations can be found on the AP Physics 1 formula sheet. However, they are used so often that it's often worth the time and effort to memorize them, as it will save you valuable time when answering questions. Here are the four kinematic equations. The first equation is relatively simple and should be used when you need to calculate the initial velocity, final velocity, time to accelerate, or the acceleration, and should be used when you know 3 out of the 4 values. The second equation is more complex. However, a common use case is when you know the acceleration of an object, such as when it is being thrown into the air or dropped off a high cliff. It's also important to note that this equation is the only one that calculates the final displacement, and that this equation also considers the initial velocity and the initial displacement. So if the problem gives any of these values, this equation can be quite useful. The third equation is similar to the first equation. However, instead of considering time, it considers displacement. It's also common to forget that both velocities are squared, so that's something to pay attention to. The first section of the fourth kinematic equation might look a bit familiar, and that's because it is. It's just another form of the d is equal to rt equation. However, instead of having rate, we now have velocity. It's effectively the definition of velocity, as v is equal to d over t. The second part just states that if the velocity rises at a constant rate, the average of the initial and final velocity can be used to substitute with velocity if the formula assumes that the velocity is constant. Let's move on to two-dimensional kinematics now, which are in a way just one-dimensional kinematics but applied to two axes. We typically solve one axis first, then the other axis next. However, it is important to keep in mind whether the object is truly accelerating in the current axis that we are trying to solve for. Let's consider a problem where a ball is moving in a parabola and that there is no air resistance, and that we are trying to solve for the distance that it travels before hitting the ground. Typically, we would use kinematics equations too to calculate the time that it spends in the air before hitting the ground. Then we move on to the x-axis, and relative to the axis, the ball is technically not accelerating horizontally, so we would use d is equal to bt, and using the time that it spends in the air that we computed earlier, and the horizontal velocity, we would calculate the distance that it travels before hitting the ground. Typically, for two-dimensional kinematics problems, we should break the problem down one axis by one axis, solve the first axis using one-dimensional kinematic equations, and then substitute the values that we got there into the other axis to get our final answer. Let's summarize. For one-dimensional kinematics, apply the four kinematics equations. These will solve most of the problems that you will ever see in AP Physics 1 regarding one-dimensional kinematics. For two-dimensional kinematics, break down the problem into two axes, and then using one-dimensional kinematics, solve for each axis one by one. Thank you for watching my video. If you liked this video, please like and subscribe, and if this video was helpful, please check out the rest of my AP Physics 1 review videos, which are linked below in the description. Thank you for watching, and bye!